Very happy to see all of you here. We're live. We have like 30 minutes, and we also have like half a minute left. So we're gonna give that time for people to come down and like take the spots. Like it's very important if you are coming in to maybe squeeze into the middle, because then other people can sit next to you, which I know is uncomfortable. But it is a conference. You self-selected to be here. So that's a part of the game. Maybe you meet somebody, like a next colleague or somebody, make a friend, learn something. Right. Before we start, let's... there are still people. Okay. I know. I have a joke. What's the scariest plant in the jungle? You'd say what? Let's try again. What's the scariest plant in the jungle? Bamboo. That's the best reaction I got for the joke, actually, so congratulations. Anyway, good morning. We're going to talk about, the session starts, we're going to talk about contract tests. We're going to talk about how you can test your applications so they break less frequently. And I'm very, very happy to be here. So this is you. Imagine this is you tomorrow. Tomorrow is Friday. You are back at work, you were inspired after the conference, you were like, I've learned so many things, I'm gonna do that. You do things, and then you commit them, and you merge them, and then it goes to production. And of course, something goes wrong, because it always goes wrong. And then you are all seasoned engineers, you are like, it is fine, it only hurts if you don't do it often enough, so it's okay that it broke. But then you have to somehow figure out what went wrong, fix it, and hopefully never make that mistake again. So what went wrong? Were your tests not good? Did you just somehow... Like, there are different types how things can go wrong, right? Like, you can just make mistakes in your code in a simple, whatever, data processing methods, and everything like false, or you forgot some checks, and then some things you can catch with normal unit tests, and you'll be fine. And then sometimes there are problems that you cannot catch with just testing your application in isolation, because the problem is at the border between interaction of two or more services. And that could be anything, right? Imagine you have a communication message that you need to send somewhere where, like, whatever transport you use, and it could be the configuration is different, right? It's just the basic misspelling of a thing, and something goes wrong. Maybe you slept on the spacebar too much, and then your YAML file got all wrong, and it suddenly still was correct YAML. Or it could be that you and your other teams at your company have different ideas of how you called your ID fields that could break things, or anything like the values that you expect to get returned, they're not returned in the correct format, and everything breaks. And that is bad. And you can build your software development process in a way that sort of reduces the risks of things like that breaking. And that, of course, the most efficient part is if you just talk to other teams. Right? The communication is key. Then you can talk, you can agree what should happen, what is the protocol, how do messages look like, what are the configurations. You talk everything out, and it works, except it doesn't work because sometimes you don't have access to the other teams. Sometimes this other team is you, but like half a year later, and it's impossible to talk to you half a year later, because otherwise you just buy Bitcoin like in the beginning, and then you don't work anymore in general. So you need a process to simplify that, and the process to kind of sort of make it easier. And that process, of course, includes contract tests. And the contract tests are the type of tests where you have two parties, two projects that depend on each other, a consumer and a producer, and they talk to each other, and you try to verify that they think about the communication in the same way, so it doesn't break. My name is Oleg Šelajev, and I work at the AtomicJar. We are doing and working on developer tooling, and we're maintaining the test containers libraries. And so that's how I got into this testing topic. And you see all my socials there. So if we don't have time here for questions, you can hit me up on any of those. And then if you are also from Tartu, you're in luck. I'm also from Tartu, so you can see me with this very stubborn but adorable dog walking somewhere around the river. So if you see us, you can be like, oh, Oleg, let's talk about test containers. I'll be very happy. He will also be very happy. He loves people. Right, so contract tests. Our production is on fire. We figured it out. We fixed it. It's all good. So what do we do? What is the reason? Did you break it, or did actually somebody else break it? Because if you think about that, there were two parties in the communication, and both are at fault when something breaks. It's the same way in the relationship. I'm old and wise, so I feel I can give relationship advice. Communication is key there as well. So, and of course it's not you. Of course it's other people who are doing things incorrectly. But in the software terms, we have two parties. We have a producer and a consumer. For example, one is the waiter who goes to a barista and asks for coffee. And then the protocol in there could be anything, and the contract tests are not sort of limited to any particular setups. It's a very generic concept. You can have normal HTTP queries there, or you can work via any protocol, or you can work via asynchronous methods of communication like message queues and so on. And the general rules sort of apply to all setups. We're going to look, in this session, we're going to look mostly at the Java examples, because that's what my background is in. So if you don't write Java, I hope you read at least a little bit. But in other languages, it would work pretty similar. Right, so let's get started. We want to have integration tests because we want to have tests that include multiple components of our system. And it is possible to create integration tests, and there are frameworks, and there is everything where you can spin up environments on demand for yourself, and it's pretty easy, except in the cases where you cannot actually create the whole environment, because you start working with other services, and other services start needing other services, so you will end up spinning up your whole internal Netflix, which might not even be possible to spin up from scratch very easily. So imagine you are that big circle, right? You also don't want to create the whole environment for your tests, because your tests need to give you a signal whether your code quality that you're actually working on, the quality of that application, is good enough. So if you spin up everything and then something in the other corner breaks, you do get test failures, but they tell you nothing. Because it's you cannot fix it because it's somebody else's code in a different project. So you don't actually want to spin up the whole environment. You want to spin up just a part of it in the immediate vicinity of your application and create the dependencies that you need for that application to work. For things like databases or message brokers, you can use, for example, test containers to create the environments. But for other services that actually implement some logic, whether third party or your local, you need to create some sort of doubles, stubs, mocks that will work and give you some sort of predefined responses for triggers, because you cannot spin up the real thing. So how do you do that? You do that with contract tests, because if you create the stubs yourself, right? It's very easy. I can write a little service, or I can write a mock that I will query and it will give me back responses. And chances are, if I'm writing that for my tests, I will encode the same assumptions I have encoded in my actual application logic. Because, well, I'm one person, right? I write my code, and I will probably copy the code or everything that I thought of into the stub that I create. So the stub alone will not guarantee that actually that thing is a correct, true double of the service that I'm trying to integrate with. So, and then it will not help. So the point is that you have to have some sort of integration where you have the tests that work both on the consumer side and on the producer side. And you test both parties, and they both agree and give you the automated signal whether they agree on the same things or not. And that is exactly what contract tests are. You have some facilities to test the producers, and you have some facility to test your consumers. For creating the environments, we're going to use test containers, which I think is the most sensible way to create isolated ephemeral test environments for your tests. Those are open source libraries. They're great. Last year at Digit, I talked a little bit about them, but there were also a ton of materials. And the most important part is that there is a whole ecosystem of modules that can give you predefined technologies with just like a few lines of code. So if you need like a Kafka container to test your services talking via Kafka, you can just say Kafka container, and boom, it's there for you. So we're going to use that in the examples, but it's not the main aspect of the session here. We're going to talk about 2 examples of how people think you could implement contract tests, and 2 different sort of implementations of the approach. One of them is Spring Cloud Contract, which comes from the Spring ecosystem in Java. And it allegedly works with also non-Java producers, but that part I only heard of. I haven't seen that working. Technically, it should work, but just saying. So it mostly works for Java. It works excellently for Spring applications. And it works a little bit like this. They define what the ideal approach that is consumer-driven contract tests. So in your producer, you start with producer. How many of you work with APIs, like either on the consumer producer side? Most of you, very good. Now, who works mostly on producers? Who like produces data and other people consume it? Not very many people, like consumers? Okay, more. Okay, cool, interesting. So, you will in luck. We're going to get to the consumer-driven things with the easier approach later, so you'll remember it better. With the Spring Cloud Contract approach, you start with the producer. And start with defining the environment, the contract, and the configuration for the Spring Cloud Contract thing to run. Out of those things, you can run contract verification tests. So the build tool, the Spring Cloud Contract Verifier, will run the automatically generated tests that verify that the producer conforms to the contract. We're going to see how it looks a little bit in the code, but you take those things and you run contract tests. And then it gives you the signal whether it's OK or not, but it also, if it's OK, what it does, it generates you the stubs of the producer automatically. So, which of course conform to the contracts that you used to create the tests. And then you use those producer stubs on your consumer side to write actual integration tests where your producer is mocked and you get those sort of predefined responses, but they are not like random predefined responses, but they're actual responses that your producer could produce according to the contract. And now, if both your contract verification tests pass and your integration tests pass on the client, you know that your applications actually are best friends and talk the same language and work correctly together. So let's see how it works. I think we have a couple of minutes here to see how it works. Where's my IDE? This is my project. Let's see. This is a simple, very simple application. Actually, there are 2 applications here in this project. We have exactly what we saw on the slides. We have a barista, which is our producer, and we have a waiter, which is our consumer application. They talk via Kafka. They are typical Spring Boot applications. So if we look at the, say, Kafka handler here, on the barista side, then it's very, very easy. Somehow the orders come in, and then through Kafka, and we consume them from the message queue. The orders come in, we process them, and we prepare the coffees. And then if coffees are good, we send them. If coffees are not good, we throw errors. This is the business logic of this application. So to enable contract tests for this, we need to create the configuration for our environment. Remember, we had 3 things. We needed the build tool support to actually generate and run the tests. And this is this. You just add the plugin for that. If you're using other technologies like Pact, for example, there will also be the configuration how to enable it in your build tools. So you create the plugin, you specify which type of tests you want to generate. Normally that would be JUnit 5. And you also specify the base test class for your tests. And this is fairly important because you need to have the setup to run the tests. Our application wants to take messages from Kafka, do something, and put other messages into Kafka. So to test this whole thing, it's very naturally that you would like to have Kafka available there for the tests. And the setup configuration, and also you need other things in the setup, like you need to teach the verifier where from to take the messages, and so on. So in your base test class that all your actual tests will inherit, you can spin up the container. You can specify that you want the particular version of Kafka, or you don't have to use test containers. This is how you create Kafka with test containers in a very idiomatic Spring Boot manner. You create the environment. You create the triggers that will sort of act as your test inputs. In your normal test, you create inputs, run a business logic on it, and then you verify outputs. So you prepare the code that could create the inputs for you. And then at the bottom there, you also create sort of the verifier. So when your tests run and the whole process goes through, your verifier knows where to look for the output messages to compare them to what the contract defined. And this is quite a bit of code, which you are like, of course, I don't want to write this, and you don't have to, because the Spring Cloud contract team created a ton of samples for you that you can just go and you just copy them. And if more people would use this approach, I'm sure they would create a more idiomatic implementation of that, so you don't have to actually go and copy code. But for now, you need to do this. So we create that, we create the base class, and then, of course, we create the contract. And the contract could be either your Kotlin file or your Groovy file or your, I think they also support YAML configuration if you're into YAML things. But in general, it looks like your actual test. You define a label, you want to call this scenario, you define what triggers the inputs, and then you define the contract, what the message should look like. And you can use all kinds of generic like placeholders in place of the normal things like timestamps or dates or IDs, or you can say like any integer or like any string would work, or you can have the actual predefined responses, what needs to be there. And then that's how the contract looks. And then of course, what you can do, you can run this thing very, very easily, right? So you just run your normal Maven, normal build tool. In this case, this is Maven. We do clean install. We could run test just to run test, but I want to run install because this is much, much cooler. So what will happen is it will generate the tests from the contract. They will extend the base class, so we'll get the setup, and then everything would work with my test containers implementation. We'll find Docker environment. Right, it will find the Docker environment. I'm using the cloud, test containers cloud for the remote Docker, so I don't need to run them locally. So it took a little bit of time to provision me, I think. So it will find my Docker environment. It will create my Kafka, and then it will run the tests. It will trigger the inputs. It will get the outputs. It will get them from my Kafka, and then it would work very, very quickly. Would it work? Let me rerun this. That's a little bit embarrassing. Okay, very good. Locally, everything is cached. We're running. And then it will give me the green responses and say that all the tests pass. If you don't believe me, then look, we're going to comment out something here, right? And then we are not sending the errors. So our producer is now incomplete. So when we run the tests, it will actually find that out, that our contract for getting errors is not matching, and then it will break. It will take a minute because it waits on the Kafka to receive that error message. And it doesn't receive that error message because our logic doesn't send it. And then it fails. We actually need it to succeed for the next step. But now you at least see that there is no trickery there. Like actually, never trust a test that you haven't seen failing. If you haven't seen the test fail, it probably tests other things, not what you expect. So the cool thing here is, when we run this, it installed of course, the jar file because we said Maven install. So it's available in our local repository. But it also, what's important, it created the stubs jar here in our local repository. In your actual setup, you will probably put it into your artifact repository somewhere. And then you can use that on the consumer side. And on the consumer side, it is a little bit even easier. Because on the consumer side, you know nothing about, you don't have to know about the contracts. You can still have your actual application. And this one is very simple. It just gets things and logs things that it got. But also in the test, what you can have the actual real integration tests where you specify the inputs. And for this application, I will actually spin up the application and hit it with HTTP requests using rest assured. I will auto-wire the stub trigger that I get from my local Maven repository, from that barista thing that we just created. And then we'll trigger that, and that will create a stubbed response and put it back into my message queue. And then I will just wait for my application to process and proceed as normal. So this is an actual, like a real integration test that verifies the whole path through the waiter application on the consumer side. And it works with the actual stub that is checked whether this is correct or not, right? So you go through this whole path. You go through this whole path that we saw, right? We started with the build tool and the environment and the contract, and we created the contract tests. Well, the build tool created the contract tests for us. We run them, we got the stubs, and we use the stubs to run integration tests on the consumer side. Both parties agree in the contract, and if the tests pass, it's all good. Now, the downside of this approach is that you need to agree on the contract, and the contract normally would reside either with the producer in the same repository or adjacent repository or in a separate repository. And it enables you to work on it as on any code, so you can send pull requests, and if you're a consumer and you want a certain API to behave a certain way, you can send pull requests to that, and then the producer team would look at that and say like, yes, very good, we're going to implement this, and then accept that, and then their test will start breaking, right? And they will have to implement that API, and then you will get it, and that's how the evolution happens. But it starts with a contract, which is a little bit of an overhead. It's easier if you're a producer, right? Because you can say, like, this is my contract, not just my schema, but like, this is how I behave, and please, everyone else, test yourself against that. But it takes some effort. So the other approach and the other popular technology for the contract test, is Pact, which they do the integration contract testing as they define. And they start with the same approach. They do the same things, but in the other order, which is, to me, it seems like it's much, much easier on the consumer side. Because you start with the consumer, and you just mock the producer using like Pact API. You create that actual mock, you run your integration tests against that mock. So that mock's like sort of embeds your assumptions about how producer works. And from those mocks, Pact generates the contract. And then that contract gets somehow to the producer side. And then on the producer side, they of course need to configure the tools and environments and everything, and they run the contract verification tests. So that means if there are multiple consumers that have different vision of what the producer API should look like, they can provide their own little parts of the contract that embed their assumptions about it. And the producer can test against all of them, and then it doesn't bother the consumer testing process, because you have to write those mocks anyhow, right? Like for the integration test, you need to have those mocks. But then you also kind of sort of integrate with the producer side, and then it allows you to be more robust in your testing process. And it looks a little bit like this, right? So let's move the coffee away from here. What we have here is two applications. They're using Quarkus, because this is another framework in Java. We have a knitter, a person or something that knits sweaters. And we have a farmer, the person who deals with sheep and then produces wool. So the knitter, to knit the sweater, needs wool. So what it does, here's an integration test for the knitter. What we do, Quarkus comes with the very extensive ecosystem of extensions that allow you to integrate simpler with particular services. They have one for Pact. You can also do this manually with just the packed integrations with JUnit, but I just had this application ready, so we're going to look at it. What you do, you define your normal tests that you want, right? And then your tests look actually as normal, and the only thing is you annotate them with the actual annotations for the packed doubles. And then you create those using the packed API where you define the mocks, where, for example, when we want to buy a sweater, we're going to have the wool order, and you can define with a very similar DSL what exactly needs to be the body of the responses or the particular bodies of the parts. And then you say that when we get the request to the certain path, we just build the response as we want using this predefined stub. And then this mock will be used on our contract side. So when I run those tests, it all works beautifully. It should work beautifully, right? It works beautifully. And then it also generates me the contracts. And they automatically get into some directory here. And it's just a JSON file that encodes the behavior of those mocks that we created ourselves, right? Like we didn't talk to anyone. We just assumed that the farmer works this way. Creates the mocks. We copy those things into the container, into the farmer, and then we can run the farmer tests on it. And the farmer tests look very much similar. It can have its normal unit tests that should pass. I think this should pass, right? This passes, all good, right? So we're ready to ship. But if we look at the integration tests, which we also annotate with packed things, and we tell where our contracts sit, then this is the whole test. We just say, like, go find the contracts and verify that we are good for it. So when we run that, it might fail for whatever reasons. So here it fails because we misspelled color, which is a very common occurrence in Britain versus non-Britain, right? So if we do it correctly, do refactor, and we rerun the test again, then it should work. And then we know that our API on the producer side is the same as our assumptions on the consumer side that were encoded using the normal your application programming language mocks, and the mocks were automatically converted into contracts. And you can do more specific sort of configurations there. You can actually check whether, for example, the particular values are there, but we will leave it for another time because this is a short session and a short demo. Right, so with Pact, you can very, very easily encode this part, and you start with the consumer, but you do all the other steps. On one side, you do integration tests against the mock. On the other side, you do verification against the contract, which is actually automatic, so you don't have to write a lot of code for that. You just do the boilerplate or use the framework support for this. And Pact is polyglot thing, so like they have implementations in other languages as well. So if you are doing specifically like a microservices systems where different services are in different languages, my first choice would be to look at Pact, even though Spring Cloud contracts say that they work with polyglot setups. I think Pact is a little bit more mature in that one in particular. Right, contracts are much, much better than schemas, even though they look a little bit the same, where you just define like the forms of the messages, but it's not. It also defines the expectation for the behavior. You can define expectations for what exactly the values are for the particular things, and you can define the stubbed responses which you want to have, and then you can verify that automatically. So it's a much, much richer tool for you. And you also don't have to have the whole schema. You can just specify the parts that you are interested in, and it works that way. And of course, the evolution of the services is also fairly straightforwardly supported with either approach, because when you get the new API version, you just test with the old contracts and you test with the currently available contracts in production. So you just run your test twice and you know that the next step is okay to make in any case, and then you deploy and everything works. So with that said, we have half a minute here left for this. So if you want to learn more about this, I'm happy to chat. I'll be here all day, so find me. If you want to learn more about test containers, testcontainers.com, Pact, and Spring Cloud Contract projects, links are there. Thank you very much for coming.